In this video, we're going to walk through the calculations to calculate the maximum diameter of this pin and its tolerance, as well as the hole for the pin in this plate and its tolerance. First, we need to start with the part print. These are 1/2 inch diameter holes with an H7 tolerance. So first, our next step is to look up what is an H7 tolerance for a 1/2 inch hole. So here in the chart, we see for a 1/2 inch hole, an H7 tolerance gives us plus 7/10,000ths of an inch. To make the allowable hole size a 1/2 inch to 0.5007. Now that I know the maximum material condition of the hole is 0.2500, that's also the maximum material condition on my pin, or slightly smaller because I need a slide fit. To determine which type of fit I should have between the pin and its hole, I should go back to the Machinery Handbook and reread the definitions. For this application, I want to use a locational fit. And a locational fit is one intended to determine only the location of mating parts. It can provide a rigid or accurate location. The type of locational fit I would like is a location clearance fit, which is intended for parts which normally are stationary but can freely assemble or disassemble. Now that I know the type of fit I want, I need to determine from the chart which one works best for my purpose. If I use an LC1 fit, the hole would have an H6 tolerance, giving the hole a feature size of 0.5000 to 0.5004 and the shaft a feature size of 1/2 inch to 0.4997. And when adding these tolerances to your drawing, don't forget, holes have a capital letter and shafts a small letter. Before I make a decision on my tolerance, I next need to consider the machining process. Remember, the tighter the tolerance, the more expensive the process. To obtain the H6 tolerance on the hole, I could ream it, I could diamond turn it, or I could cylindrical grind it. And to obtain the H5 tolerance on the shaft, I could diamond turn it or again cylindrical grind it. An LC2 tolerance would give us slightly more tolerance and could be machined with using the same methods as the LC1. Again, the LC3 will give us a bit more tolerance and is machined using the same methods as the LC2 and 1, where the LC4 is definitely too large of a tolerance for this part's function. Before we decide on our final part tolerance, we have to remember the hole size we're locating from only has a tolerance of 7/10,000ths of an inch. 50% of that is 3.5/10,000ths of an inch. So the only shaft tolerance that meets this criteria is the LC1. Therefore, our hole in our guide plate will have an H6 hole tolerance, and the shaft or indexing pin will have an H5 tolerance.